I want to find the equation of the tangent line at each of these points. Remember, the equation of a tangent line is y minus y1 equals dy dx, x minus x1, or x1, y1 is my point. So I already have my points. I just need to find my derivative and then evaluate at each of the points. So my dx d theta is going to be 3 sine theta, and my dy d theta is going to be 2 cosine theta, which means that my dy dx is going to be 2 cosine theta over 3 sine theta, or 2/3 cotangent theta. So let's look at the points. So at the point -1, 3, if I look at the point -1, 3, and I figure out what my theta is, what I can do is I can say that -1 equals 2 minus 3 cosine theta, which tells me that -3 equals -3 cosine theta, or cosine theta equals 1, which means that theta is 0. And at the point 2, 5, I can say that 2 equals 2 minus cosine theta, and I can say that 0 equals cosine theta, so theta is pi over 2. And finally, at the point 4 plus 3 radical 3 over 2, 2, I can use a sign, so I know that 2 is 3 plus 2 sine theta, or -1 is 2 sine theta, and so sine theta is -1/2, which gives me a theta at 7 pi over 6. And remember that we're going to use the inverses and where they're defined. Oh, actually, because we know that it's going to be 7 pi over 6 in that quadrant, the third quadrant. So now what I'm going to do is I'm going to find out what my slope is. So at theta equals 0, well, the cotangent of 0 is undefined, which means my line is going to be a vertical line, so it's x equals -1. And at pi over 2, my slope is going to be 0, so it's going to be a horizontal line, or y equals 5. And finally, at 7 pi over 6, I have 2/3 the cotangent of 7 pi over 6, which equals 2 radical 3 over 3. It's 2/3 times radical 3. And so the equation of my line is going to be y minus 2 equals 2 radical 3 over 3 times x minus 4 plus 3 radical 3 over 2.